So, we have a problem, and that is that the electricity bill in this house is very, very high. And truth be told, we don't really know why. We've tried tracking it down to a few different things, but it's kind of getting to the point where we want to try figure out what the root cause of this is and what might be. So, to try and figure out this problem. So, right here we have what is known as a PZEM-004T V3 breakout board. Now, what this board is it allows you to measure power, and what's quite handy about this is that it has an output that will allow you to connect it to directly to a computer, or in my case it's going to be connected to a microcontroller that will feed the information to an app that I can monitor over time. So basically, the way in which this device communicates with the Arduino or microcontroller or computer is via a serial connection, a UART connection. So that happens here. Your 4-pin connection here, so I've just made this up on the fly. That slots in there, and what I've done here is connected the ends of these wires to DuPont connections, which will be connected to your Arduino or microcontroller. For the final version, I'll probably make these a bit more reliable connections, but for a temporary setup, this will do the job. And what happens is there's actually a little processor here, and what that does is that does all the analysis of your power or your logging of it, and then that transmits that over a serial connection to your Arduino. Now, one quite nice feature about this board is that the connection between the live side, so where the high power is going through, and where your microcontroller is connected to, are separated. So it means that if, worst case scenario, this explodes because too much power goes through it or something goes wrong, say there was a surge in your house, your microcontroller in theory shouldn't blow up, which is always a nice feature. So some of you are probably wondering why go to all the effort of working with this quite big breakout board that has all these extra connections, when a lot of the time you could just use a split core transformer and connect that either to a small breakout board or even no breakout board, but connect directly to your microcontroller and not have to worry about all these extra features that this has, such as having to interface with a serial connection to an Arduino or microcontroller or whatever. And very good point, and the reason for that is when I was looking up how to monitor power accurately, I kind of realized that measuring AC power gets quite complicated quite quickly, and this board actually does a lot of the measurements, takes that off your hands. It gives you a lot more measurements that I'd have to think a lot harder about to try to figure out how to get an accurate reading, and truthfully I just don't understand, but I figure I kind of want to have them just in case. So this thing is able to measure not just the current, but also the energy, the frequency of the power factor, and the voltage itself. So you get a lot of extra features without having to do a lot of thinking, which is why I like this. Okay, so before we go putting this directly into the mains breaker, I thought we'd just do a quick run through how this is actually going to work. We can do our testing on a small scale setup before going to a mains, before going to the big boys. So, what is this? Well, this is a little plug I rigged up just to do some temporary testing on this. It has two sets of wires connected to this point. So the idea being it will mimic how the mains connection is done. So if you can imagine, you see where this wire goes. This wire is connected to this plug here. Right. This is going to be simulating our circuit to the rest of the house. So in other words, the power, so your load will go through here, and the idea being we want this device here to measure the load coming out of this. By load, I just mean the amount of electricity being pulled. So say you have your laptops, your computers, blah, blah, blah. The amount of electricity going through this. So how do we go about that? Well, don't know if you can see here, but I've stripped back the wires here to expose the 3 wires that we're interested in. So we have live, neutral, and ground. It's actually the opposite. That's live, that's neutral, that's ground. Anyway, doesn't make too much of a difference. What will be happening is we have our split core transformer here. That is going to be going around one of the wires as such. And that will be monitoring how much current is passing through here. Alright? Next up, we have this wire, which only has 2 connections going to it, the live and the neutral. We don't need the ground for this device here. And that wire, let's get it here, connects directly into the PZEM-004T version 3 onto these 2 connections here. And what this will do, this will monitor what the frequency of the power is, and what the actual voltage at this source is, because the voltage source here will be the same voltage that's going through here. So that's our basic setup, and next up we'll show you how it's actually kind of put together.
Okay, so here we're going to very quickly run through the software. I'm not going to go in depth or anything, just to give an overview of how you go about it and how you approach it. So here we're using the Arduino PZEM library. Of note here is when you're dealing with microcontrollers or the like, you can have serial connections in a few different ways. So you can have what's known as hardware serial, where you have 2 pins on your microcontroller which are dedicated for serial connections specifically, or you can use any other 2 pins and have what's called software serial connections. Software serial connections are they're not as fast, you can't get as high speeds, but the advantage is you can pick any 2 pins here. So that's what we're going to be using here, software serial. So we've just picked pins 6 and 7 in this case. So we have to declare them at the start here with this line here, and this just lets the Arduino know that we're using these 2 pins for our serial connection. The second thing you're going to have to do is to display the data connect to the module itself, so you're doing 2 things at once. You need to set your speed of the serial connection. In this case, for the PZEM and for your display, you have to use 9600, this line here. The Arduino library comes with a different speed by default, and that doesn't actually work, or at least I couldn't get it to work. So this is the general library here. It doesn't do anything special, it's just printing your voltages, your currents, power, all this kind of stuff, waiting 2 seconds, and then displaying it. And this is essentially what we'll be using. A lot of this is actually handled by the program we'll be using, but behind the scenes this is kind of what it's doing anyway. So very minor changes and we can get ourselves up and running. The only catch we have is that we actually have multiple devices, and when we deploy this we want to actually use the same 2 pins, if that makes sense. So you want to have 4 different energy monitoring devices all connected to the same 2 pins. So I'll show you how to do that next, how you'd actually register it so that you can have multiple devices talking along the same 2 pins. Okay, so here we have the sketch we'll be using to actually allow us to call multiple power monitors using the same 2 pins. So the way we do this is actually quite straightforward. So what we'll do is we'll assign an address to each power monitor. So the start of here is the exact same since we're registering it on pins 6 and 7. This is the speed, serial speed we'll be using. And here's where it gets a little bit different. So we have to set the address in this kind of form here with 0x04, it's hexadecimal version of a number. And we just run these commands here, which is just simply set address, the address you want, and all this is doing, otherwise just printing out the address so we know what we've set it to. Really, it's just this one here that you need. So yeah, that's it. So the way we'll be implementing this is that we'll have 4 devices. So we'll have 4 different addresses. So for example, 0x02, 3, 4, 5. I think it can hold 70 plus devices. So allows us to really efficiently use just 2 pins to address a large number of devices, which is what we'll be doing. The only thing of note here that there are certain addresses you can't use, like 01, I believe, is like a global address. So in other words, if you were to plug in just one device and it had been set to an address, but you still want to call that address without that device without knowing its address, you could just use a specific address that would broadcast any and all. But you can't use that address if you've got multiple devices on it, if that makes sense. So there's certain addresses you have to avoid, but 2, 3, 4, 5, 6, 7, 8, 9, that's fine. You'll figure it out pretty quickly if you give it a go yourself. The other reason we're doing it with these Arduino stretches rather than in the program itself is because the program we'll be using, called ESP Home, actually doesn't have a feature that lets you set the address using that program. So while it has a feature to call to a specific address, it doesn't have the ability to write a power monitor to a specific address, if that makes sense. So it means that we have to determine what the addresses are. We have to set the addresses before connecting it up to that. So that's why we're going to all this effort here.
Okay, so here we can see the setup, hopefully around this type of area. Here you'll be able to see what the power readings are. As you can see, there's nothing connected up and we're basically getting 0 output here. So for a bit of fun, I just picked up a random plug I had lying around, just happened to have this glue gun on hand. Once I plug this in and this turns on, you can see there that straight away we're starting to draw more power there. So our power has automatically jumped up to 50 watts, 60 watts. It'll probably keep rising, or okay, 50 watts. Anyway, so if you can think of this glue gun here representing all the electricity in the house, all the appliances, this will be able to measure them as such. And you can see here we're getting a bit of an increase in a few different things, such as the energy, the power factor. And to be honest, the energy and the power factor are 2 things I probably wouldn't been able to work out, but this device just makes life a lot more simpler by figuring that out. So once I remove that, you should see there that the power, there you go, instantly drops back down to 0. Okay, so here we have the final product. Now, not sure if you can see here, but we have our 4 power monitoring modules. Those are connected up using these wires to this, which is known as an ESP8266, which is just like an Arduino but with Wi-Fi built in. The wire coming out of that's just running back to the plug, and that just provides power to the rest of this little circuit board here. So similar to what we had before, but just repeated 4 times over. So 4 separate addresses, all connecting to the same RX and TX pins on the microcontroller, i.e. the Arduino, i.e. the ESP8266 in this case. So we have 4 wires here, and to these we have our clamp terminals. So this is what a fuse board looks like with the panel taken off. So as you can see, these are our breakers here as we go along, and what we want to do is we want to essentially clamp onto those to measure how much power is coming through. So here we can see an example of one there, and that is monitoring the amount of power going through this, which supplies the rest of the house. So that's how that works. For demo, I'll show you this one here. I'll explain why I'm focusing on this one in a second. But you can see here you have both a brown wire and a blue wire coming out of the same fuse. As you can see, we have our clamp going around the brown, which is, I believe, the live. Blue is the neutral. And in the same two ports we have also this wire. So this wire is plugged into the two ports there, and that's measuring a voltage across it. So again, remember, this is measuring the voltage, and then this is measuring the current. And so those feed into here. And in the vast majority of cases, that is job done. This fuse board is a little bit different because we have what's known as three-phase power, and it's sort of laid out a little bit differently. So you can see on these fuses fuses along this line, there's only brown wires coming out. The reason for that is that rather than there being one live and one neutral coming out of each fuse, we have one live and then one big neutral coming out of one side. So in other words, all of these fuses share the same neutral. So for that reason, if we look closer here, you'll see the very first, the leftmost wire here, we have our clamp coming in there, and then we have the voltage coming in. And then what I've done, just for simplicity's sake, rather than having lots of wires coming out of this, I've just used the same voltage across all of this. But that shouldn't make a difference because it's just showing what the voltage is. So anyway, yeah, that's it. You can see here, every now and again it flashes. Those flashes means it's taking a reading. I have it set to take a reading, I think, every like 5 seconds or something, because I want it to be more or less live. And yes, that's the setup there, really. So just one other point that I forgot to mention earlier, and that is the main reason, or I suppose another reason, why I connected all the voltages off this one fuse here, as opposed to taking different wires from different places and having each of them individually connected up. So while it would be, I suppose, more accurate, one of the big advantages of having this setup here, where all the voltage in the entire setup comes from just one switch there, is that when I'm working on those, i.e. when I'm hooking up the clamps, all that kind of stuff, I don't want there to be any high voltage coming from that, because that is a big danger. As you can see, the terminals there are kind of small. It's easy to slip to accidentally touch something that you shouldn't have, and then best case scenario, you fried your circuit. Worst case scenario, you fried yourself. So by having it connected up onto this one breaker here, if I want to work on this, to do it safely, I just flick that down, and now you can see there, the top's still blinking because that's powered by that, but underneath here, there's no voltage across there. It's completely safe to touch. Whereas if I flick that on, lights are coming on, high voltage there. So just a point to consider from a safety perspective. Now as well, from another safety perspective, that really should be fenced off so that no one can actually touch it. But yeah, make a casing around it. That's the word I was looking for. So I should really make a casing around that. That is going to happen. I actually plan on adding a few more of these modules in, so this is only a temporary setup, but that is planned for the future, to have a casing to stop people touching that and getting fried alive.
Okay, and so to just round it off, this is what the actual result of all the work looks like. So you see here we have 4 kind of panels. Each of these panels corresponds to one of the power modules we installed. And you can see here it lists out the current, the power, energy, power factor, all that stuff. So all in one, very neat, very aesthetically pleasing application. So this is called ESP Home. You can access it from anywhere in your browser once you run it. I'm not going to get into how this is set up. Sorry, this is called HomeAssistant. I'm not going to get into how this is set up because it's a whole other topic. But say, for example, we look at this panel here. We can click on what we want, and it's been recording data for a while. This is just displaying the last day, and you can see we can easily have a look at to see when the power is particularly high, what the power draw is, so that in other words, this is corresponding around when we start eating and turn on the immersion heaters to heat the hot water in the house, etc., etc. So it gives you quite a good insight. And yeah, so again, this is displayed with HomeAssistant, and the program itself that's controlling the sensors is called ESP Home. I won't get into it, but you essentially you register your device here. Then you just tell ESP Home what these devices are and what you want from them. So there's the PZEM modules, you list out what the address is, and then you tell it what you want. In other words, current, voltage, energy, readings, all that kind of stuff. And yeah, so it displays it neatly on these panels, and that's really it. Thank you very much for watching, and sure, mind yourself.